Okay, let's see now some definitions as we are moving forward with this. Again, please, as you are watching this video, write your notes, write your questions, so we can use them later. So we said atoms are going to react, and this based or because of their reactions, they are going to form something called a chemical bond. Now, these chemical bonds are electrical attractions, whether they are weak or strong, they are electrical attractions that will bring two atoms together or more. Now, when we are saying electrical attraction, it means that these are energy relationships, meaning that there is no physical connection between them. It's just like they are staying together because they are attracted to each other. In our textbook, they are considering a molecule is a result of formation of a bond between two identical atoms. Like here, for example, we have hydrogen and oxygen molecules. Oxygen, basically two oxygens in this case, and for the hydrogen, it's also two hydrogen in this case. However, if the molecule or if the compound is made out of two different atoms, like this one, like water, this is called compound. Now, my understanding that even in many textbooks they are using molecule to describe what they are referring to as a compound. So we might be able to use this word to describe like water. Now, remember, uh, why do the atoms need to get into chemical bonds? Basically, they need to fulfill their octet rule, that they have to have 8 electrons in their valence shell to be stable. Okay, so whenever an atom is in need 4 electrons either to go or to come, that's when the atom would engage into a chemical bond. What we are going to see in this chapter, 3 different types of chemical bonds, and we will start with the ionic bond. Now, with the ionic bond, if you remember, before going to this, let's just recap. We said we usually will have equal numbers of protons, or the number of protons will equal the number of electrons. And in this case, we will have a net charge of 0, right? Or neutral net charge. Now, but this is not always the case because we saw that there are atoms are tending to lose electrons, and there are atoms going to gain electrons. Again, to fulfill the octet rule. So, in this case, let's see this example. We have the sodium. This is the sodium, and this is the chloride. As we talked earlier, the sodium has 11 electrons. So we'll focus from now on only on the electrons. Okay? We won't care too much about the protons, and of course we are not caring too much about neutrons. So the sodium has 11 electrons. Where are they? 2 in the first shell, 8 in the second shell, and only 1 in the valence shell. Right? So with this here, with this electron here, we understand that the sodium atom is super unhappy, is very unstable. Unstable. And it wishes that this electron to go away. Because if this is gone, if this electron is gone, the sodium will have 8 electrons in its valence shell and it will turn into a happy one. So this is one case with the sodium. On the other hand, we have the chloride. The chloride has 17 electrons. Okay, 2 again, first shell, 8 in the second shell, and 7 in the valence shell. 7 electrons. Now, for the chloride, in order to fulfill the octet rule, it has 2 options, either to lose these 7 electrons or to gain 1 electron. And of course, as you can guess, it's much easier to gain an electron rather than losing 7 electrons. And who is willing to give the electron is the sodium. So this electron will literally jump from the sodium and join the chloride. Literally will jump from the sodium and join the chloride. The chloride, because it's a big atom, will be able to attract this electron. The electron would feel more attracted to the chlorine comparing to the sodium, and that's why it's going to leave the sodium. And of course the sodium would be happy. Now the sodium, it has 8 electrons in its valence shell. It's happy, okay? But also remember, now it has 10 electrons. However, it still has 11 protons. These are positive, this is negative. So the net charge will be positive, right? So it will be one positive sodium ion in this case. We'll call it ion. Since it has a charge, it's ion. And technically, a positive charge, it's cation. Okay? Cation. An ion is a charged atom. Whether it's positive or negative, a charged ion is a charged atom is ion. Now, when it is positively charged, is cation. Now, for the chloride, remember it has originally it has 17 electrons, but now it has, with this one, it has 18 electrons. So it's 18 electrons and 17 protons. So now it's what? It's minus 1. So the chloride would display a negative charge. So what does this mean? It means now we have a positive sodium and a negative chloride. And what happens when positive and negative sit beside each other? They will get attracted to each other and they will form NaCl. That is the table salt. Okay, so in this case, what happened, that we established that there are 2 atoms oppositely charged and they are going to get attracted to each other. Remember, why they are oppositely charged? Because one atom, in this case the sodium, lost its electron to the chloride. Okay, and that caused the attraction between the 2. And this is basically the ionic bond. Okay, this is the same thing. Now salt or NaCl will crystallize when it's dry, and it's easily associated or deassociated in water. So when we put salt in water, it will disappear. Why? Because these ions are going to get away from each other. However, the sodium will not get its electron back. So it will remain an ion. Okay? And the same thing, the chloride would keep the extra electron. So with ionic bond, this transfer of electron is like, you can think of it as permanent. It's done. It's not going to be irreversible. It's not going to be reversed. Okay? Now, you can pause here and go over the ionic bond. Make sure that you clearly understand it before moving to the covalent bond. For covalent bond, the main thing about it that here we are sharing electron. In ionic, the secret or the magic word was gain and lose. But with covalent bond, it's sharing electron. Okay? So here, the atoms are not going to lose or gain electrons permanently. Rather, it's sharing. It means that the electron is going to spin, or the electrons are going to spin around the two atoms endlessly. So each atom will having 8 electrons in its valence shell. Okay, so we will see it that these electrons are going to spend time around the two atoms. And in this case, each atom would feel that it has 8 electrons in its valence shell. For the covalent bond, we have two types, polar and nonpolar. Let's start with the polar covalent bond. With the nonpolar covalent bond. Now, if you remember, we said the hydrogen molecule, it's two hydrogens, right? Now, the hydrogen is a super tiny, little cute. I usually call it the cutest atom in nature because it's a proton. Like this is the hydrogen. It's a proton and electron. Super tiny and cute. This is the hydrogen. So for the hydrogen, its valence shell is just one shell. Okay? So for it, it's not the octet rule, it's the dual rule. That in its valence shell, it has to have like 2 electrons to feel stable or to feel happy. In this case, we'll draw them in different color. Let's assume that this electron belongs to this hydrogen atom. This electron belongs to this hydrogen atom. Okay, so each hydrogen atom is providing 1 electron into this shared space between them. So this couple of electrons are going to spin around both atoms. So at any given time, if this hydrogen is counting how many electrons it has 2. The same thing, if this hydrogen is counting how many electrons it has 2. So this is a covalent bond. And because it's just one pair of electrons, it's a single bond. It's a single covalent bond. Let's see another example. Here we have oxygen. This is oxygen, remember, O2. In this case, oxygen, before that, oxygen has 6 electrons in its outermost shell. 1, 2, 3, 4, 5, 6. So it's missing 2. So one oxygen will talk to another oxygen. Okay, I'm missing 2, you are missing 2, let's share them. So both oxygen atoms are going to share pair of electrons. And this pair, and in this case, the 2 pairs of electrons are going to spend equal time around both atoms. So at any given moment, if this oxygen is counting how many electrons it has in its outermost shell, it will be 1, 2, 3, 4, 5, 6, 7, 8. Okay? And the same thing, if this oxygen is counting how many electrons in its outermost shell, it will be 1, 2, 3, 4, 5, 6, 7, 8. So both are fulfilling the octet rule. Another example is CO2. CO2, remember, oxygen has 6, the carbon has 4 in its valence shell. So technically, the carbon needs 4 more electrons. Right? So it will come and take 2 electrons from each oxygen molecule. And in this case, this pair of electrons, actually these 2 pairs of electrons are going to spend equal time around these 2 atoms. And these 2 pairs are going to spend equal time around these 2 atoms. At any given moment, if the carbon is counting how many electrons it has in its valence shell, it would be 1, 2, 3, 4, 5, 6, 7, 8. The same thing for this oxygen. It's 1, 2, 3, 4, 5, 6, 7, 8, and so on. And in this case, it's CO2 because we have 2 oxygen atoms. Now, in both cases, in this case and in this case, we are sharing 2 pairs of electrons. In this case, it's double bond. It's a double bond. Now, we have also in nature like cases when we have 6 electrons shared, like the case of nitrogen. In the case of nitrogen, nitrogen is very unique. Let's see this. Where is it? Because nitrogen has 5 electrons in its valence shell. So this is one nitrogen. Let's say this is another, this is another nitrogen. This nitrogen is missing 3. This is missing 3. Okay, they will talk to each other. Let's do it. So they are going to share 3 pairs of electrons, and these pairs are going to spend equal time around both atoms. And in this case, this is like a triplet covalent bond. Okay, this is a triplet bond. Okay, now in all of these examples that we have seen, I said that these electrons, these shared electrons, are going to spend equal time around both atoms. Equal time around both atoms. And technically these are the nonpolar covalent bond. The nonpolar covalent bond. So because the electrons are going to spend equal time at each atom. And this is usually will give us neutral nonpolar. Now, to understand what does it mean nonpolar, let's try to understand what does the polar mean. Now, let's go back to here. An example of a polar molecule is HCl. We said the hydrogen, this is the tiniest and the cutest atom in nature. It has only one electron, whereas we have the chloride. This is like a really giant atom, and it has 7. Let's assume this. The hydrogen needs only 1. Needs 1. The chloride needs 1. They will come and talk to each other. Give me your electron. No, you give me your electron. I have only 1 electron. I can't give you, like, I'm missing only 1 electron. So we can't form ionic bond. Why? We said because ionic bond involves gaining and losing. Not the chloride, not the hydrogen. None of them is going to gain or lose any bond. Therefore, they decide, okay, let's share electron. Each one of them is going to provide, throw it in different color, 1 electron in between. And this would result that we have hydrogen and we have chloride sitting beside each other with a pair of electrons. And these pair of electrons, in ideal condition, they are going to spend equal time around both atoms, right? But this is not the case. What is happening is that this pair, one of them from here, this pair of electron, and because of the enormous size of the chloride, is going to spend more time around the chloride, and this time around hydrogen. Let's say like every 10 rounds around the chloride, there is 1 round around hydrogen. Okay? Every 10 rounds around the chloride, 1 round around the hydrogen. Which means that the chloride, or the pair of electrons, let's write it, pair of electrons is spending more time around chloride and less time around hydrogen. Now remember, the hydrogen did not lose its electron, and the chloride did not gain that electron. At any given moment, if they decided to break, the hydrogen will keep its electron and the chloride will keep its 7 electrons. Okay? But as long as they are forming this covalent bond, this is the situation. More time around the chloride, less time around the hydrogen. Now, because the chloride, or because the pair of electrons is spending more time around the chloride, remember the chloride has 17 protons and 17 electrons. But now there is, most of the time, there is extra electron around the chloride. For the hydrogen, it was 1 proton, 1 electron. But in this situation, since that pair of that hydrogen, that electron is spending less time around the hydrogen would feel that it lost its electron. It's not complete loss, and the same thing here, it's not complete gain. However, since there is more time of the electron around the chloride will start to feel that there is extra electron in my valence shell. And therefore, it will display a negative charge, and it's partial negative charge. This is delta. This is like, we will say like minus delta. Okay? So it means like partially or temporary negative charge. The same thing for the hydrogen. The hydrogen, since it's lost its electron, so it's only now, it's a proton. It's a positive charge. So it feels that it's partially positive or temporarily positive. So the hydrogen would display a slight positive charge. The chloride will display a slight negative charge. So which means that we have HCl, a compound, that at one end it's like partially positive, and other end it's partially negative. Now, because of this reminds us of basically a battery. Remember, battery, one end is positive, the other end is negative. This is like the positive pole, this is the negative pole. And that's why this looks like a battery. This is the negative pole, this is the positive pole. That's why this is polar covalent bond. That's why it's polar, because now it has 2 poles. Okay, it has 2 poles. The pair of electrons, because the pair of electrons is spending more time around the chloride, less time around the hydrogen. However, HCl as a compound, it has no charge. Only when we are looking at the details of it, we will see the slight positive and slight negative. But as the unit, as a big unit, as HCl, it has no charge. Okay, so this is the polar covalent bond. A polar covalent bond is a result of unequal sharing of electrons. and equal sharing of electrons. Okay, I will pause here, I will stop here. Take your notes, go over this again, write your questions, and take a break. When you come back, we will resume talking about the hydrogen bond and other stuff.